today we are going to talk about covalent bonding. Covalent bonds happen between two nonmetals, and those are typically our anions. They want to gain electrons. So they will be everything to the right of the red line. So everything in blue, including some elements on the red line, as well as hydrogen. Hydrogen is also considered a non-metal. In this video, we are going to go through examples on how to show covalent bonding with Lewis structures, and we're going to go through the rules as we do so. So our rules for drawing covalent bonds with Lewis dot structures is first we need to draw the Lewis dot structure of each of the elements and atoms. We need to place the elements with the least number of valence electrons in the middle. And that is true for all elements except for hydrogen. Hydrogen will never be placed in the middle because it only has one valence electron and it can only add one more valence electron. It can only have two total, and so it can't really share that many electrons compared to other elements. Our second step is to locate the lone electrons. Our lone electrons, those are the ones hanging by themselves. So, for example, if I have fluorine, all the ones circled in red, those are our lone pairs. And then the ones circled in blue, that is our lone electron. And our lone electrons will be used in covalent bonding, and they're going to create a shared pair. And what that means is there is going to be a pair of electrons shared between two elements. So after we draw the line connecting those lone electrons to create those shared pairs, we need to check to make sure all of our atoms, elements, Lewis structures have met the octet rule. So they all want to have 8 valence electrons. Our first example is going to be H2O. So we know that hydrogen is going to have 1 valence electron, and we have 2 hydrogens. And then our oxygen is going to have 6 valence electrons. So we want to put oxygen in the middle. Remember, we cannot have hydrogen in the middle. So I'm going to go ahead and draw oxygen with its 6 valence electrons. And then we are going to draw hydrogen with 1 valence electron. And you kind of want to put those lone electrons towards the center because they are going to be the ones bonding. And you don't want to create like a really weird squiggly line. You want your lines to be straight. And so we need to locate our lone electrons. So I'm going to highlight our lone electrons in green. So we have a lone electron here. So we have 1 lone electron on each hydrogen, and then we have 2 lone electrons on oxygen. So they are going to create a shared pair, 1 electron from oxygen and 1 electron from hydrogen. So this right here will be our shared pairs. And those electrons are going to be used to create those covalent bonds. So to draw our covalent bonds with our Lewis structures, all you're going to do is instead of like circling the 2 electrons to show that they're shared, you're just going to draw a line from one to the other. Each line equals 1 bond or 1 shared pair. So now we need to make sure that both hydrogen and oxygen have met the octet rule. So I'm just going to check. We'll start with oxygen first. Oxygen has 2 right here, 2 right there, that's 4. It has 2 in the shared pair, and 2 in the shared pair, and that makes 8. So oxygen is good to go. It has 8 valence electrons. Now we need to check hydrogen. So for each hydrogen, they are sharing 2 valence electrons. And for hydrogen, that means that they have met the octet rule, because hydrogen only wants 2 valence electrons. If you remember our Bohr model of hydrogen, the first ring, the first orbital, can only hold up to 2 valence electrons. And so that is considered a full octet for hydrogen, because that's as many as that orbital can take. And so all of these have met the octet rule, which means that this is the correct covalent bond drawing with the Lewis dot structures for H2O. Our next example is S2. So I'm going to go ahead and draw 2 S's, and then we need to know how many valence electrons they have. So if we locate S on the periodic table, that's sulfur, it's in the column with 6 valence electrons, so they're each going to have 6. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And remember, you want those lone electrons towards the center. And so for each sulfur, we have 2 lone electrons. And to create a shared pair, we need 1 from each. So we're just going to draw our line from here to here, and that creates 1 shared pair. And then from here to here, that creates another shared pair. And so we need to now check to make sure that there's 8 valence electrons for each sulfur, so that they have met the octet rule. So our first sulfur has 2 shared pairs, which are the ones in red. So there's 2 electrons in that shared pair, 2 electrons in that shared pair, which makes it 4. And then we have 2 lone pairs, and those are the pairs of electrons that aren't shared between 2 atoms. So here's another 2 and another 2. And so altogether, this one has 8 valence electrons, and this one has met the octet rule. And again, the other sulfur again has 2 shared pairs, so that's going to be 4, and then 2 lone pairs, which is going to be another 4. It also has 8 valence electrons now, so this one has also met the octet rule. So that is the correct Lewis structure for S2 that shows the covalent bond. And this is called when there are 2 bonds between 2 elements, like so. So sulfur has 2 bonds, 2 shared pairs. That is called a double bond, because there are 2 bonds. Like we said earlier, 1 bond equals 1 shared pair. For H2O, however, there are 2 single bonds, because there is only 1 bond between oxygen and each of the hydrogen. So even though there are 2 bonds, there's only 1 per oxygen and hydrogen shared pair. So there would be 2 single bonds. It is only considered double when there is more than 1 bond between 2 of the same atoms. And so our last one is CF4. So we know our carbon is going to have 4 valence electrons. And we have 4 fluorines, and they are going to have 7 valence electrons each. And if you're wondering where I got those numbers from, if you find carbon and fluorine on the periodic table, so here's carbon, here's fluorine, the number of valence electrons is this number above on the column. That is where I got those numbers from. And so our first rule is that we have to draw the lowest dot structures, and we want to put the atom with the least number of valence electrons in the center. And so here, the one with the least number of valence electrons is carbon. So we're going to put carbon in the center. And we are going to draw its 4 valence electrons. Remember, 1 on each side before we can pair up. And then we're going to draw 4 fluorines. And we're going to draw a fluorine on each side of carbon. And so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Remember, you want to put those lone electrons towards the center because those are going to be the ones involved in bonding. Okay. So we know that carbon has 4 lone electrons, and if we look at fluorine, fluorine only has 1 lone electron. So for each fluorine, there's only going to be 1 lone electron. So for every lone electron on carbon, it's going to match up with a lone electron from fluorine. So we're going to draw our line from fluorine to carbon to create a bond, and that is our shared pair. So here's another shared pair or our bond. Here's another, and there is our last. And now we need to make sure that they each meet the octet rule. So carbon has 4 shared pairs, and in each shared pair there are 2 valence electrons. So carbon has 8 total. So carbon has met the octet rule. Now for fluorine. Fluorine has 3 lone pairs. Each fluorine has 3 lone pairs, so there's 2 valence electrons in each of those lone pairs, and then we again get 2 from our shared pair, so that would be 8. 6 from the lone pairs, and then 2 from the shared pair. And so fluorine meets the octet rule, and that's the same for all the fluorines. So all of these would meet the octet rule, and because they all meet the octet rule, that means that this is our correct Lewis dot structure for CF4. And for this CF4, there would be 4 single bonds. And that's because there is only 1 bond between each fluorine and carbon. And so just to recap, when you are doing covalent bonding, you are going to have 2 nonmetals, and they are going to be sharing valence electrons. It is not like ionic bonding, where there would be a transfer and you could give one to another atom. Covalent bonding is going to be sharing.